Alrighty. All right, so normally we do not take the time to watch the videos in the slide deck, but this one is a good one. It's only 2¼ minutes long, so that's how we're going to start off class today. We're going to use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. So everybody pay attention to this video, please.
All right, sometimes we're going to find ourselves and we're looking at a graph and we say to ourselves, you know what, I want to get from this delicious looking cake over to this wonderful piece of cheese. Well, I can't read on a graph how far that is. There's no sure way for me to count, well, it's 1, 2, 3. It doesn't work out exactly. So, luckily, we've learned about the Pythagorean theorem. And the Pythagorean theorem is actually going to give us a great way to solve these types of problems. Notice I have my green line here. Well, if I were to make a line down here and then cut straight across, I've now created a right triangle. And I know how to find the distance of my C, or my hypotenuse, in a right triangle. All I have to do is find out my side lengths, and then I can use the Pythagorean theorem, which remember is a squared plus b squared equals c squared. So let's take a look and see if we can find our side lengths to start. 1, 2, 3, 4. So I have a side length of 4, and I'm going to call that side A. Then I have a side length of 1, 2, 3, and I'm going to call that my side length B. Now that I have those two pieces, I can come up to my formula and figure out my missing information. So if I'm looking, I know that A is 4 squared plus B, which is 3, and then squared, equals C squared. Well, I know 4 squared is 16, 3 squared is 9, and I add these together, and that's going to give me my C squared. Keep it on the same side here, guys. I have a lot of people who want to add that 25 and then put it over where the C's at. Keep it all on one side of the equal sign. It's going to treat it like an equation. It's going to make sure we don't get things mixed up. So 16 plus 9, like I said, is 25, and that equals C squared. But I'm not finished here, right? I don't want to know what C squared is. I want to know what C is. So to get rid of that square, I have to square root it. I do it to both sides. 25, the square root of 25 is 5, and so that is the length of C. And so now I've found out that my delicious looking cake is 5 units away from my fabulous piece of cheese. So that's one way we can use Pythagorean theorem on a coordinate plane.
All right. See, wasn't that short and sweet, everybody?
All right, sometimes we're going to find ourselves.
So we are still using the same standards and learning targets as we used last week because we're still working on the Pythagorean theorem. So I'm going back up to the beginning of the slide deck. So these are the standards that we are going over today. And then these are our learning targets. We've already met most of these learning targets, and today what we're working on is this one right here. We are applying the Pythagorean theorem to find the distance between 2 points on a coordinate system, okay? All right, let me get back down to where we started, and we have some practice examples to look at, some practice problems. All right, so here we have a triangle. So you can easily count the distance of horizontal lines and vertical lines. But when you have a diagonal line, it's hard to count these because this looks like almost 1 unit, but then it's hard to count from here up to here. There's not exact points that this is going through, so that's why we have to use the Pythagorean theorem. All right, so if they give us this point and this point here, we are going to create a right triangle. It's the first thing we're going to do. Now, they decided they were going to make the right triangle go, they were going to, let me get my pen going here. They said, all right, we're going to make our right triangle right there, this way and over here, but we could have also done it going straight across to the right and down, okay? Ooh, look at that. Just pretend to be straight line. So even if we did our right triangle above the 2 dots, we're still going to get the same unit. So for example, from here to here, how many units is that? 1, 2, 3, 4, 5, 6, 7, 8. You got it. And now we're going to count from here down to this dot. So that would be 1, 2, 3, 4, 5, 6. So that's exactly the numbers they got when they made the triangle below the dots. Okay. So does 8 and 6, what two letters does 8 and 6 have to be?
A or B.
A and B, exactly right. So it doesn't matter which is A and which is B, but the distance that we are missing is definitely C because that becomes our hypotenuse of our right triangle. So what is 8 squared, everybody? Yep.
64.
64. Some of you were chatting me. I appreciate that. What is 6 squared, everybody?
36.
36. That's exactly right. And what does 64 plus 36 equal?
99.
99? So close. Is it 99?
100.
I think it's 100. Exactly right. So does that mean C is 100 units long? No, C squared is though. So how do we find the square? How do we get C by itself? What do we do to both sides? We
Find the
find,
square root.
we find the square root. Exactly right. So the square root of C squared is C. And what's the square root of 100? Yep,
10.
y'all are chatting me the answers. Some of you are telling me the answers. Brilliant, brilliant, everybody. Good job, good job. All right, let's look at another one, please. All righty, same thing here. Now, when you do your Delta Math assignment this week, it only has the dots. It doesn't have any part of the triangle for you. Okay, so you guys have to come up with the right triangle, either above the 2 dots like this one, or you can make it to the right of the 2 dots. Okay, all right, so can you guys see well enough to count? What is the distance between this corner and this corner? Six. Yep. Several of you are chatting me that as well. All right. Can you guys see well enough to count from here to here?
That's 8.
Is it 8? I don't think it's 8. It's 1, 2, 3, 4, 5, 6, 7 is what I'm counting.
Oh, I thought when I looked at it, I thought the red thing was on the 4.
Oh, yeah. Well, it is on the 4, right? So from 4, so we're moving from 4 to -3. So from 4 to -3, we would move 7 spaces. Okie dokie. All right, so we're going to use the Pythagorean theorem. A squared plus B squared equals C squared. So we already know 6 squared is 36. What is 7 squared, guys?
49.
49. That's right. Very good. All right. Who can tell me what 36 plus 49 is?
85.
85. I agree. C squared is 85. So now we're going to find the square root of both sides.
What I have the answer. Where should we round it to?
Let's round it to the nearest tenths. TENTHS. So are you going to tell me, Colin? Oh, Colin told me the tenths. Yep. I love it. I love it. I love it. All right. So if my calculator says 9.21 and we're going to round to the nearest tenths, we're going to look at this number in the hundredths place, correct? Since the number in the hundredths place is a 0, 1, 2, 3, or 4, what happens to our 2? It stays. Yep, it stays at 2. So a couple people told me the answer was 9.3, but make sure you round correctly. If this number was a 5 through 9, then yes, we would round the 2 up to a 3, correct? Yeah. All right. Not too shabby, right, guys? This should seem easy to you because we have been practicing Pythagorean theorem for over a week now. Okie dokie. All right, so I know if you don't have this printed out, it might be difficult for you, but jot down your 2 side lengths if you can. And I want everyone to message me the length between these 2 dots, please. All of you, ready, set, go. All right, y'all are already telling me because the numbers keep repeating over and over and over. Aren't we having the same numbers over and over and over? Yes.
I realized that. Did I tell this sister said? I'm like, now she must have did it on purpose.
Yep, that was not on purpose. I apologize. I should give y'all much more challenging assignments. So once again, this is a 6 by 8, isn't it? So we've already done this pretty much. Right, a 6 by 8. What did we do earlier? 36 plus 64 is 100. And what's the square root of 100?
10.
It's 10. All right, we got to find some really, 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 really hard ones for y'all to do. Hey, here's 6. Okay, so there's 6 of these. I want all of you to find the distance for 3 of them. So you're going to send me 3 answers and please label them so I know which ones you're doing. All of you, 100% of you are sending me 3 answers. Are you ready? Get set, go.
Don't forget to round it to the nearest hundredth.
All right, I was doing them when you guys were, so I haven't been able to tell you if you're right. So Colin, it looks like I agree with you. Allie, you're supposed to be writing them as decimals, you silly goose. Ashlyn, number 6 looks right. Colton, number 1, I disagree with, unfortunately. Sabdi, number 3, I disagree with. That's what I got for number 2. What you got for number 3? Ashlyn, 3 looks good. 6 looks good. 3 looks good. Kira, number 3 is what I got for when you said number 2. Rylan, I agree with all of them, but number 5. Jimena, that looks good. All right, I haven't heard from all of you. Naomi, good, good, yes. Isaiah, for number 1, I got 7.2. Maybe that was a typo, I'm not sure. Ashlyn, I like it, I like it. All right, so for number 1, I counted the side lengths as 1, 2, 3, 4, a 4 by 1, 2, 3, 4, 5, 6. So remember, if you're using your calculator, or ooh, that's supposed to be a 2. Just pretend it's a beautiful 2. If you're using your calculator, you can just put the whole thing in at once, right? Are you guys doing that? Yep, Rylan, I agree with you. Yep. So if you put the square root of 4 squared plus 6 squared rounded, I got 7.2. And of course, if I messed up, y'all tell me, please. All right. So for the second one, we got a 1, 2, 3, 4
Also
by.
round to the nearest hundred.
Oh, I did tenths. Oh, it does say that. Colin, guess what? I wrote those directions. Dang. You're so smart. All right. 1, 2, 3, 4, 5. So this is a 4 by 5. So the square root of 4 squared plus 5 squared is 6.4. Do we all agree? 6.4? Yeah. All right. Number 3 is a 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5. So for number 3, I got the same thing as number 1. No, I didn't. Oh, it shouldn't be that. I think I did the same dimensions. What'd you get for number 3? Did I mess up on that one?
I got 7.2.
You got 7.2. That's what I have, but that's what I got for number 1, it looks like. No, it's supposed to be 7.8. Yep, it should be 7.8. Do y'all agree? Yes, Hayden got the same thing. Okay, I did the same thing though. I got 7.2, but I used 4 and 6 like I did on the first one, so I missed that one. All right, number 4 is a 10 by 6. A 10 by 6 would be 11.7. Number 5 should be a 9 by what? 4? A 9 by 4 triangle would be a 9.8. Y'all tell me if you disagree with me. And then number 6 would be a 1, 2, 3, 4, 5 by 2. So 5 squared plus 2 squared. The square root of all of that is 5.4. All right, who did great? Who got them all? Yeah, who only missed one? And you see why? Who has a question about this? Nobody? Nobody has a question? Hey, Brady, I see you came on in. Let me mark you here. All right, guys. Will you let me know if you have any questions? Will you guys let me know if you have questions? You promise? Okay. All right, so that is basically what we're gonna, does anyone need help? Yes, Colin is also an excellent help. All right, so we started off talking about the Pythagorean theorem by looking at this picture. So who's gonna be really, really brave and unmute and tell me what this picture symbolizes? What is happening there? What are they showing us? Any brave souls out there? None? All right, so they have filled up these 2 squares right here. At first, these 2 squares are filled completely. And when they rotate that table, it shows that those 2 squares fill up the biggest square perfectly, which just confirms the Pythagorean theorem. If you take the square of the 2 sides, if you square the 2 sides and add them together, it equals the same area as the hypotenuse squared. Okay, so that's a great visual of the Pythagorean theorem. All right, so there are a couple more challenging questions on this slide deck. I double dog dare you guys to figure out the answer and send those to me, and I will give you a little extra credit for the week if you will finish slides 44 and 45 and give me those answers. All right, so let me show you what your assignment is for tomorrow.
Where do we submit it? Where do we submit?
You can
Wait.
just send it to me via Canvas inbox.
Oh, okay.
Okie dokie. All right, so for tomorrow's assignment, the one that's dated for tomorrow, it looks like this. A treasure map, but it says math treasure. It's got to be the best treasure in the whole world, everybody, a math treasure. I know, I know you're excited. All right, so what you're going to do is you're going to use your Kami tools and you're going to create right triangles between the treasure box right here. You got to read the directions when you open the assignment and each of these pictures. So we're going to see what is the distance from the treasure box to the X. So I'm going to come up here. Here's the X. Here's the treasure. So I'm going to come over here to my shapes. Under shapes, I have a straight line. Okay. Everybody watching me? All right. So you are going to draw a triangle. So I can either go across here or I can draw my line across this way. It doesn't matter. Either one of those is going to be fine. So I'm going to go ahead and make my pink line there. And then you're going to make a line to go up to your X right there. And then, of course, to make our right triangle, we're going to connect our treasure box and our X. And that line tool makes this so easy because y'all have never, some of you have had me for 2 years. You know I cannot draw a straight line with my little pad and my little pen, right? But here they're perfectly straight. All right, so now I'm going to label the dimension. So how tall is this right here? What is the distance from this X to this line right here? Yep, 1 unit, you got it. So I'm going to label 1 right there. And then how far is it from this corner to the treasure box? Ryland's holding up 5 fingers. 1, 2, 3, 4, 5. Very good, Ryland. I agree with you. So I'm going to label this as 5 right here. So I have a triangle that's a 1 by 5. So I'm going to come down here. It tells me to show my work. So I'm going to pull up equations. I'm going to go to this pi symbol. Everybody with me? Am I going too fast? Oh, Ashlyn got kicked out. She's coming back in. Oh, somebody's chatting me. Let me see. Okay, you guys are answering my questions. Thank you much. So I'm going to pull up the little pi symbol, and then I'm going to start typing radical. Radical. Well, when I searched for it earlier, it came up. Do you guys see a radical? Colin, you did this. How did you find your radical? Oh, there it is right here. Right there. Do you guys see it?
I was gonna say if you can't find it, I just searched up the word root and it popped up.
Root. Okay, so that's good advice. If you can't find it, search the word root. All right, so I just inserted this radical. All right, go away.
Can I say something quickly about this assignment?
Yep.
It's probably gonna be the easiest one we did all year.
You
Not
think
the
so?
the fun ones we're gonna do at the beginning and end of the year.
All right, I'm hitting it, but it's not typing. Colin, do you know? I mean, I've done this before. After you type the number, hit that.
You click it, then you hit then you hit it,
Mm-hmm.
and then you
Oh, there
click
it
the back
is.
arrow. And go.
Okay.
Yeah.
Okay. All right. So now I'm under it. All right. Let me get rid of this thing. All right. So now there's my little radical. So I'm going to type 1 squared. So 1, and then my little equations for my, this thing. So I'm going to do 1 squared plus, and it's a 5 squared, triangle, or the other side is 5 squared. Okay. And then I'm going to get rid of this. So now I want to make this bigger. I mean, obviously you guys probably can't even hardly see that. So I'm going to do this thing over here. I'm going to pull it down here. Come over here, please. Yeah, it takes a minute to figure out how to use Kami, but once you got it, I think you got it. All right, so what is 1 squared plus 5 squared? The square root of that would be the square root of what? 26. So the square root of 26 is 5.1. So there's my answer, 5.1. All right, so it takes a minute to get used to using Kami, obviously. Okay, Isaiah, thank you for coming back. All right, so I showed my work. I showed how I found my answer, and I drew my right triangle up here. Okay, so that's what you guys are going to do on your assignment tomorrow. All right, does anybody have any questions about that? All right, so we do actually have 15 more minutes. So I do want everyone to go ahead and open up tomorrow's assignment. So I want you to go to today's, this week's Math Canvas course, please. Colin, you've already done this, so you're good to go, buddy. I want everybody to go to tomorrow where it says Treasure Map 11:15. I want you
Bye,
to pull.
everyone.
Bye, Colin. Thank you, buddy. I want you to do at least, I've already done number 1 for you on your assignment. I did for number 1 for you. And now I want all of you to go to the second one, and I want you to give it a shot, and I want you to tell me what question you have, if any. Okay? So all of you are working in Kami for the next 10 to 15 minutes. Okay? I'm going to be quiet, but let me know when you run into a problem.